Hi everyone, I am Premal Goel and my roll number is 23104063. Today I am going to explain three important controllers in our control system, that is proportional controller, integral controller and derivative controller. These controllers are widely used to improve system performance like stability, accuracy and response speed. So let's start with the proportional controller. Let's see the block diagram of a control system. This is our input RS, then comes a summer block, then here we get an error signal ES that goes into a controller. A controller produces a control signal, that is MS, which derives the plant or the system. We represent it as GS, and then we have feedback path, which is the output goes into the feedback, which further goes into the summing block, and here is our output CS. In this controller, the output is directly proportional to the error. Here, this means MS is equal to KP into ES, where KP is the proportional controller gain, or we can say the proportional gain. Now, this error function ES can be represented as RS minus FS, feedback signal. Okay, ES is equal to RS minus FS. Now we can write this MS as KP RS minus of FS. Now we can write the transfer function, that is output CS upon RS. In this case, when the controller gain is KP, the transfer function will look like KP into GS upon 1 plus KP into GS into HS. This is the transfer function of a control system with unity feedback. Here we have considered a negative feedback. So in this transfer function, we have a positive here. And as KP is like in series with GS, so it will be multiplied and the result will be like this. This is the transfer function of a closed loop system. And the shape of the output of proportional controller is same as the input to the controller. We can see this using an graph like amplitude. This is time t, and this is our input to the controller. And as we have seen that KP is directly multiplied with the input and this is the output. So if KP is greater than 1, then the amplitude will increase and the output will look like this when KP is greater than 1. Whereas when KP is less than 1, the output will be looking like this. Output in Kp is less than 1. As Kp is directly multiplied to the input, so there will be like this, the change in amplitude of the output. Now let's understand what happens when the Kp changes. First case, when the Kp increases. When the Kp increases, we have a faster response of the system. We will understand this using a diagram also, but first we will write these points. A reduced steady state error as well. Steady error. But there is also a disadvantage when Kp increases, that the overshoot will highly increases. Therefore, the stability of the system, of the overall system, decreases. Whereas when the Kp decreases, the response of the system will be slower. And there will be more steady state error, and the system will become more stable here. Become more stable. Let's understand this using a graph. This is amplitude. This is time t. So when the value of Kp is lower, the graph will be smoother and will take much time to reach the same level. Whereas, this is the value of Kp. Whereas when the value of Kp will be higher, there will be more overshoot and it will take less time to reach the same level as above. You can see using this, and this is less time taken when the value of Kp is higher, whereas when the value of Kp is lower, the time taken is more. So this was the effect of Kp. Now we will discuss a proportional controller and for a second order system with unity feedback. So the block diagram goes like RS, that is the input, which goes to a summer block, proportional controller gain, and this is the plant or system of standard second order system, which is n square s into s plus 2 eta omega n. And here is the unity feedback. And the CS. This is the output. This is input. This is negative feedback. This is the controller gain Kp. Here comes error signal. And this is the signal ms, which is produced by this controller block. Now we can write the transfer function as Cs by Rs, which is equal to Kp into omega n square. As these are in series, so we will multiply these upon s into s plus 2 into omega n divided by 1 plus Kp omega n square s into s plus 2 eta omega n. which will be resulting as Cs upon Rs, which is equal to Kp omega n square divided by S square plus 2s eta omega n plus Kp omega n square. This is the transfer function of a second order system with unity feedback with controller block and controller gain Kp. So now the advantages of the proportional controller is that it is simple and easy to implement. And it improves the speed of response of the system, and whereas it has some disadvantages as well, that is it cannot eliminate steady state error, which can be reduced using other controllers like integral controller or differential controllers, which we will be studying in further videos. And also a disadvantage is that high gain can make the system unstable. So this is it for proportional controller. We will be studying the other controllers, that is integral controller, differential controller, in the next upcoming videos. This is it for this video. Thank you.